Let's talk about why simulation is so relevant for project-based education. First, what is it? Video games like Fortnite or Minecraft can be considered simulation. We differentiate by using the term physics-based simulation, implying that what the user sees on the screen is attempting to mimic the real world. Think of it this way. Physics-based simulation takes the equations from a textbook, like Maxwell's equations, puts them into a form that only a computer can love, like this sparse matrix, and then applies numerical techniques to efficiently and accurately solve problems, like this antenna, that are simply too complex to solve analytically using the original equations. The objective is always to provide useful information to the user. So how do we know what's useful? Most users of physics-based simulation are engineers who are interested in designing and building things, and they have figures of merit in mind. Will the wing of an aircraft provide the right amount of lift at takeoff, or will there be too much drag for a given angle of attack? Will the dozens of wireless devices in a modern home, like cell phones, game consoles, and smart light bulbs, interfere with each other? Simulations provide evaluation of early design concepts that can help answer these types of questions. But it doesn't stop with early assessment. Simulation models can become very complex and accurate and account for any number of environmental conditions or use cases. They serve as a prototype that can be tested against the laws of physics, all within a computer. In fact, we use the term virtual prototype to differentiate between the physical test article and the simulation model. This is where project-based engineering and simulation complement each other. There is no better way to teach the concepts of iterative design than through meaningful projects where simulation and physical prototypes are part of the plan from the very beginning. Here is how it's done today across all disciplines of engineering and industries. Start with the idea or concept. Build the virtual prototype along with the system requirements and verification criteria. Generate the results. If it doesn't meet the requirement, or the requirement perhaps changed, iterate the design here before spending time and money on the physical prototype. When the detailed design is acceptable, proceed to the physical test article or directly to the product manufacture stage. You'll find that most students really enjoy running simulations, especially when it's tied to a challenging and interesting project. Once they go through an iterative cycle the first time, they'll pick up the concept fast. As a teacher, you'll benefit from simulations and can use it to support the math, physics, and engineering concepts in your curriculum. In another segment, we'll introduce some concepts and terminology that will help you start your journey in virtual prototyping.